Welcome back to Thinkpharma YouTube channel. So this is our last class to alkaloids. So before in previous classes we have studied about what is introduction to alkaloids, what are alkaloids, types of alkaloids, properties of alkaloids, and then we have studied each class like piperidine and pyridine alkaloids, then quinoline alkaloids and propane alkaloids and isoquinoline alkaloids. So today we will study about purine alkaloids, caffeine, Tropolone alkaloids, imidazole alkaloids, rest of the things. Okay. So moving to the purine alkaloids. Purine alkaloids are nitrogenous compounds with a purine structure. Okay. So this purine structure is having two rings which are heterocyclic aromatic in nature. So I said you these purine alkaloids are having two rings. So this is six-membered pyrimidine ring. It is fused with five-membered imidazole ring. Okay. So I told two rings are present in this purine alkaloids. So in that two rings, one ring is six-membered, that is pyrimidine ring, that is fused with five-membered imidazole ring. So this structure is having totally 5 carbon atoms and 4 nitrogen atoms in it. Okay. So purine ring system is a fundamental building block of nucleic acid, including DNA and RNA and other biomolecules. So next, these purine alkaloids examples are coffee, coca and tea. When coming to coffee, the biological source of coffee is ripe seeds of Coffea arabica or Coffea liberica, which belongs to the family Rubiaceae. And the main chemical constituents present in it are caffeine, theobromine, and theophylline. So, main uses of this coffee is CNS stimulant. Okay, so this caffeine also used as diuretic. So the main class present in this caffeine is methylxanthine class. Okay, so it acts as a stimulant, so which affects CNS. Okay, and then next use is it leading in, then it is leading to the increased alertness and energy. So when you will very stressed or bored, then if you will have some coffee in you, then you will feel like refreshed and you will feel like you got some alertness and energy, right? And the next use is it blocks the effects of adenosine, which is a neurotransmitter and that promotes sleep. Okay, so this will result in wakefulness. So when you are studying for exams, so at if you're doing some night study and all, then what you will do, you will have some coffee or tea, right? So which will make you to stay for long time, which will make you wake. So that is because it is blocking the effect of adenosine, which is a neurotransmitter. Okay. And then next use is excess intake of caffeine, which leads to anxiety and insomnia. Okay. So if you are taking in less mg of this caffeine, then you will get CNS stimulant effects. And if you are taking this caffeine excess intake, then that will lead to anxiety and insomnia. Okay. So next one is coca. So the biological source of this coca is obtained from ripe seeds of Theobroma coca. So the family is Sterculaceae and the main chemical constituents present in this coca is theobromine and the main use is CNS stimulant. Next one is tea. The biological source of this tea is, so this tea which was obtained from leaves and leaf buds of Theasinensis, which belongs to the family Theaceae, and the main chemical constituent is caffeine here and the use is CNS stimulant. So main uses of this purine alkaloids, if we are telling, then it acts as CNS stimulants. Next, moving to next class, phenylethyl amine alkaloids. Okay, so here we can see example, that is ephedra, so which is also called as mahong, common name or synonym. And then next, biological source. So ephedra, which is obtained from the stems of Ephedra gerardiana or Ephedra neprodensis, which belongs to the family Netaceae or Ephedraceae, and the main chemical constituents present in this ephedra are ephedrine and pseudoephedrine. So these are the two active chemical constituents which are present in ephedra, and the use of this ephedra is bronchodilator in asthmatic conditions. Okay, next moving on to this tropolone, which is or amino alkaloids. So this tropolone is non-benzenoid aromatic compound. Non-benzenoid in the sense it is having 7 ring. Okay. Then next, So example is colchicum here. So colchicum, which is also called as meadow saffron seed or autumn crocus. Okay. So the biological source of this colchicum is the colchicum, which was obtained from the seed of dried ripe seeds of colchicum luteum or colchicum autumnale, which belongs to the family Liliaceae, and the main active chemical constituents which are present in this colchicum are colchicine, which is used for gout and rheumatism treatment. Okay, so this is the use of this colchicum. Next, moving on to the imidazole alkaloids. So, imidazole is a five-membered heterocyclic aromatic ring where you can see three carbons are present and two nitrogens are present in that ring structure. Okay. So, example is pilocarpine, which is also called as jaborandi, common name or synonym. So, next, moving on to the biological source, this pilocarpine, which was obtained from leaves of Pilocarpus jaborandi or Pilocarpus microphyllus, so belongs to the family Rutaceae, and the main active chemical constituents which are present in this pilocarpine are pilocarpic acid and isopilocarpine. The uses of this pilocarpine are glaucoma treatment. Okay. Next, these all are main classes of alkaloids, and then next we will move to other alkaloids which are present in this classification. That is steroidal alkaloids, which example is kurchi. Okay. Common name or synonym is Hollerania. Then next, moving on to the biological source of this kurchi is stem, this kurchi which was obtained from stem bark of Hollerina antidysentrica, and which belongs to the family Apocynaceae. So the main active chemical constituents which are present in this kurchi is conicin and norconicin, and the use is amoebic dysentery. Next drug is veratrum. So the biological source of this veratrum is it was obtained from roots and rhizomes of Veratrum viridae or rhizome of Veratrum album, which belongs to the family Liliaceae. The main active chemical constituent which is present in this veratrum is proveratrin, and the use is insecticide. Insecticide in the sense that will act against insect, okay, that kills or it inhibits the growth of insects. Next drug is ashwagandha, which is also called as Indian ginseng or Withania root. The biological source of this ashwagandha is it was obtained from roots and stem bases of Withania somnifera, which belongs to the family Solanaceae. And the chemical constituents which are present in this ashwagandha is steroidal lactones, withanolides, withanine. So these are the compounds which are present in this ashwagandha. And then next, the uses of this ashwagandha is immunomodulatory drug and sedative hypnotics. Then next drug is lobelia. So it is also called as Indian tobacco or asthma weed. The main biological source of this lobelia is it was obtained from aerial part of lobelia nicotianaefolia or lobelia inflata, which belongs to the family Campanulaceae. And the main chemical constituent of this lobelia is lobelin, and the use of this lobelia is respiratory stimulant. And next, coming to the next drug, areca nut, which is also called as betel nut. So the biological source of this areca nut is areca nut, which was obtained from the seeds of Areca catechu and which belongs to the family Palmae. The chemical constituents which are present in areca nut are arecolin, and the uses are parasympathomimetic agents. And then next, coming to aconite. Aconite, which is also called as bachnag or monk shoot. The biological source of this aconite is it was obtained from the root of Aconitum napillus, which belongs to the family Ranunculaceae, and the main chemical constituent which is present in this aconite is aconine, and the use of this aconite is treatment of neuralgia. Next, coming to Vasaka, which is a very familiar drug, which is also called as Adathoda or Adulsa, and the biological source of this Vasaka is the Vasaka which was obtained from leaves of Adathoda vasica, which is a scientific name, and then the family is Acanthaceae. So the main chemical constituents present in this Vasaka is vasicin and vasicinone. The uses of this Vasaka are expectorant and bronchodilator. So with this, we have completed alkaloidal classification. So thank you everyone. Keep watching Thinkpharma YouTube channel for more updates regarding this pharmacognosy subject. Hoping that you all are getting some knowledge regarding pharmacognosy.